All right, so we're just starting our new unit on energy and thermodynamics. And what we're going to be doing in this video is we're going to be going over some practice questions in which we do some heat calculations while there's a temperature change. So we're going to be doing some heat calculations in the future next week where there's no temperature change. So it's important to take note that these are when there is a temperature change. And we're going to be using the same exact formula for all of these questions. So it's something we should write down in our notebooks. And we use it so much we'll probably have it memorized. So we got Q equals C times M times delta T. And we'll talk about what each of these things mean right now. So Q means our heat. So Q is our heat, and there's a couple things I want you to take note of. If it is positive, that means it's absorbing heat. It's getting warmer. But we could also have a negative Q. So if something's losing heat, it's giving heat to its surroundings. Think if you have a hot cup of coffee, it's losing heat. Something can have a negative heat there. That would be if it's releasing heat. All right, so that's our Q, talking about our heat there. C is what we call specific heat. So we're going to be going over this in our notes in quite a bit of detail. All you need to know right now is every substance has its own very unique specific heat. I got a table right here. This will also be on Google Classroom. And you can see water has a specific heat of 4.184. Something like aluminum would have a specific heat of 0.897. And what this means is it is how many joules, that's a unit of energy, how many joules of energy it takes to heat 1 gram of any of these substances 1 degree Celsius. So this will be the unit we use for each of these. And if you want to think of what does a high specific heat mean, like water has a pretty high specific heat, or something like lead would have a really low specific heat. The higher the specific heat, the more energy it's going to take in order to increase its temperature. So if you've ever put water on a stove, water has a really high specific heat. So it takes a long time to heat up and a long time to boil. Whereas iron has a lot lower specific heat. So if you've ever put an iron pot on the stove and forgot to put water in it, that iron pot heats up very, very quickly because it has a low specific heat. It takes a low amount of energy to increase its temperature. So we have this table to tell us what different substances specific heats are. And that's what we put right here. Then we have M, which will be mass. Really easy. We just get that from a scale or in the problem somewhere. I'll use a different color as we go through these ones. This will be mass. And that'll be in grams. So I'll put that right down here. Mass in grams. And then right here we got delta T. That means it's our change in temperature. Delta just means it's a change. Change in temperature. Specifically, the way we calculate this, instead of writing a delta T in your formula, you could put in parentheses temperature final minus temperature initial. So we could even use that instead of delta T in our equation. So we're going to be using this, and we're going to be going through those 5 practice problems I gave you. I recommend trying them on your own first. Once you have your own answers, that's when you should watch this video, check your answers, see if you did it correctly. All right, so I'm going to be writing our equation down first for this question so I don't forget it. We got Q equals C times M times, and I could put delta T here, but I'm going to put T final minus T initial. I'm already going to put that in there. And we'll read through here, and then we'll read through it again and underline important things. So here it says, how much heat does a 23-gram ice cube absorb as its temperature increases from negative 17.4 to 0 degrees Celsius? So let's underline some key things here. How much heat? That means I'm looking for the amount of heat. I'm looking for Q. So Q is going to be my question mark. That's what I'm trying to find here. All right, and if I keep going, it says, does a 23 gram, that is going to be my mass. So I could put right here, mass is equal to 23 grams. And it tells me the substance, ice cube. That means the substance I'm dealing with is ice. So, because I know what substance it is, that also tells me what my specific heat is. So, we don't need to memorize this. We'll have a table here. The specific heat of ice is going to be 2.03 joules per gram Celsius. And then we have our final temperature here. So we could say how much does it absorb as its temperature increases from negative 17.4 to 0. So our temperature of a final would be 0. And our temperature of initial would be negative 17.4 Celsius. Note that this is a negative here. So when I'm doing the math, it'll be 0 minus negative 17.4. So it'll end up being a positive number. And as we go through here, another thing that helps us know that we're going to get a positive number here is if something is absorbing heat, it's going to have a positive temperature increase. So let's throw all our numbers in here and we'll calculate it. So we'll write out Q, that's what we're looking for, equals 2.03 joules per gram Celsius times our mass. So times a mass of 23 grams times our change in temperature, which is 0 minus negative 17.4. So we can just write 17.4 degrees Celsius. And this is where we're going to bust our calculator out. So let's get our calculator out. Multiply all these together. 2.03 times 23 times 17.4. And we should get about 812.4. Our heat is equal to 812.4. And our units will be joules, because that is the units that we had in our specific heat. So that is our answer for question number 1. Let's jump into question 2. Question 2 is a little bit different. All right, so in this one, we'll read it out and then we'll talk about what we're looking for. A sample of unknown metal has a mass of 120.7 grams. As the sample cools from 90.5 to 25.7 degrees Celsius, it releases 7,020 joules of energy. What is the specific heat of the metal? And what is the metal? Remember, it's a specific heat is an intensive property. That means it can help us identify what the metal is. So we're looking for specific heat in this case, which means all we have to do is kind of change what the equation looks like. So if we start with Q is equal to C times M times our delta T, and we're trying to figure out our specific heat. We're looking for C. All you gotta do is a little bit of math here. You divide both sides by mass times delta T. Let's see, I'll do that in a different color. Divide both sides, because we could divide both sides by mass times delta T. It'll cancel out here. And what you'll get is C is equal to Q over mass times delta T. So that's what we're going to be solving this time. Same equation. And if you wanted to, you could have just plugged all the numbers in here. But I like to, figure out what I'm solving for on one side and plug all the numbers in on the other side. All right, now let's look for what each of these are. So a sample of unknown metal has a mass of 120.7 grams. So our mass is equal to 120.7 grams. As the sample cools from 90.5 to 25.7, so our delta T here is going to be, here's our final, that's what it's going to, 25.7 minus 90.5. We're going to have a negative delta T here because it's cooling off. So let's figure that out right now. 25.7 minus 90.5. Our change in temperature is negative 64.8 degrees Celsius. So we got that right here. And then something else we have is it releases, that is another key word right here, releases 7,020 joules. So that would be our Q. And your hint here, releases, tells you it's losing heat. You could also get that from your negative change in temperature. It's losing 7,020 joules. So now we got all these things to plug in here. All right, so if we plug these in, it'll be negative 7,020 joules divided by 120.7 grams and negative 64.8 degrees Celsius. So we're going to plug all these in the calculator. Something that I like to do, especially when you got a couple things you're dividing by, is always push equals afterwards so you know you're doing the correct operation. So we're going to start with negative 7,020 divided by 120.7, and I push equals there. And then we're going to also divide it by this. So divided by negative 64.8 degrees Celsius. And we get our answer there. C is equal to 0.8975, and our units are joules per gram Celsius. So we're halfway there. We have our specific heat. We just need to figure out what metal this is. So remember, it's an intrinsic property. We can use it to identify what metal it is. So here's our specific heat. It's right around here. So our metal would be aluminum. All right, moving on to question 3. And again, same exact equation, so we'll write it out here. All right, what is the mass of a sample of iron if that sample lost 2,300 joules of heat when it cooled from 80 degrees Celsius to 30 degrees Celsius? All right, so look in here. Let's take a look at what we're doing. We're looking for mass. What is the mass? So we have to rearrange this. So we're calculating for mass. And we could do that, again, just by dividing both sides by specific heat and change in temperature, because that will cancel those two out, leaving just mass on this side. And we got to do the same thing to both sides. So this would make our mass equal to Q divided by specific heat times our change in temperature. So now we got to calculate everything else we got there. We got our sample of iron. You know what? We got iron here. And if we have iron, we know our specific heat. So we could already find what C is. So let's take a look. Iron has a specific heat of 0.449 joules per gram Celsius. If that sample lost 2,300, all right, so right there we know our number. I want you thinking in your head, you think that's positive or negative? And it would be negative because we lost that heat. So negative 2,300 joules of heat when it cooled from 80 degrees Celsius to 30 degrees Celsius. So we got to think delta T, final minus initial. Our final was 30 degrees Celsius minus 80 degrees Celsius. So we don't need a calculator for this one. 30 minus 80. Our change in temperature is negative 50 degrees. Again, just plug them all in. Our mass is equal to Q, so negative 2,300 joules divided by 0.449 joules per gram Celsius divided by negative 50 degrees Celsius. And just throw that all in the calculator, see what we get. Negative 2,300 divided by 0.449. All right, so we got this number. And then 50 is below the fraction, so we got to divide again. Divide by negative 50. And this will be our mass, about 102.4. We'll round it there. 102.4 grams. 102.4 grams of iron. All right, and these next few are a little bit trickier. So let's take a look at these. Maybe you might have had trouble with questions 4 and 5. I'm going to write it out a little differently this time. Q equals C times M times TF minus TI. Remember, that's all change in temperature is. And we're going to use that after I read this here. So 15.6 gram sample of ethanol absorbs 868 joules as it's heated. If the initial temperature of the ethanol is 21.5 degrees Celsius, what is the final temperature of the ethanol? So here, we're looking for final temperature. So the math here to get final temperature on one side is a little bit harder. If you want, you could plug all these numbers in and solve the math that way. But again, I'm going to try to isolate our temperature final before we find anything. So for here, we're going to divide both sides by specific heat and mass. And we'll get temperature final minus temperature initial is equal to Q. Oops, that shouldn't be there. Q over specific heat times mass, just like that. So again, we want to isolate final temperature. So what it would look like is final temperature is equal to heat divided by specific heat and mass plus our initial temperature. So that's where we're going to be throwing all our things in here. And again, if this was a tough jump for you, just throw your numbers in here and calculate. All right, so let's get everything from our problem. First, we got a 15.6 gram sample. So that's our mass right away. Mass equals 15.6 grams. Our next thing that you could take a look at real quick is it's a sample of ethanol. So that's where we get our specific heat. We have to know what substance it is. Ethanol, let's get this paper out here. Ethanol, specific heat is 2.44 joules per gram Celsius. 2.44 joules per gram Celsius. And then we could say it absorbs 800. Absorbs is a key word there. Absorbs 868 joules. Think now, if something's absorbing heat, is it going to be positive or negative? And absorb, it's going to be getting warmer. It'll be positive, 868 joules. If the initial temperature of the ethanol was 21.5 degrees Celsius. So that is what our TI is going to be. 21.5, a little bit sloppy. 21.5 degrees Celsius. Throw everything in there. So this would equal 868 joules divided by 2.44 joules per gram Celsius, and the mass of 15.6 grams. Well, I'm running out of room here. After you do all that math, we have to add 21.5 degrees Celsius to it. So let's get our calculator out. 868 divided by 2.44. And I always like pushing equals after everything I do. And then this is on the bottom side of the fraction, so we have to divide by 15.6. Divide by 15.6. And then we have to add our initial temperature before we have our answer. So from here, add 21.5, and there's our answer. So our final temperature equals 44.3 degrees Celsius. All right, I'm gonna bring this one back because you're gonna find that the next question is very similar to this. So rather than go through that whole explanation again, we're gonna bring that same equation back. All right, so in this one, we have A 50-gram object with a specific heat of 0.3825 joules per gram Celsius releases 4,593 joules of heat. If the initial temperature is 235.16 Celsius, calculate final temperature. So you can see, same type of problem. We're calculating final temperature. So I'm going to borrow the same thing that we've already worked out here. So temperature final is equal to heat divided by specific heat and divided by mass plus our initial temperature. And you know what? We could just plug everything right in as we read through it here. All right, so first we're starting with mass right here. 50 grams of an object. So we're going to throw 50 grams right where mass goes. With a specific heat of 0.3825. Throw that right where C goes, because that's specific heat 0.3825. And we're going to try to squeeze those units in there. Joules per gram Celsius. Releases 4,393 joules of heat. So think, is that a positive or negative number? That's going to have a really big shift on our final answer. We need to know if it's increasing in temperature or decreasing in temperature. And that release tells us it's negative. That also is going to tell us that it's decreasing in temperature too. And then if the initial temperature is 235.16 degrees Celsius. So right here, we got everything we need to throw it all in a calculator. Negative 4,593 joules divided by 0.3825. And again, you're going to see me push equals here. So I know I do all my order operations correctly. And I divide again by 50 because 50 is below the fraction there. So divided by 50. And now, all right, my phone cut out, but to show you how that last problem ended, after we added the initial temperature, we should have gotten a final temperature of -5 degrees Celsius after finishing this problem.